Welcome back everybody to linuxacademy.com. My name is Terry, and in today's course we continue our preparation for the Linux Foundation Certified System Administration exam. In today's video specifically, we're going to be talking about how to install software packages. Very specifically, we're going to be looking at the Debian or Ubuntu based versions of software and package management. Now, if you are running a CentOS or Red Hat based distribution, we do have a video on package management using those tools, but this one will specifically be for Debian or other Ubuntu based distributions. Now, for package management and package installation for any software package in a Debian or Ubuntu environment, we're going to be looking at three different tools, and they do things a little bit differently each one. For strictly installing .deb packages, which is the package format that Debian and Ubuntu systems use, we would be using the dpackage command. And if we take a look at the man page for dpackage, once we log into our Linux Academy server, so we'll go grab that IP address, and we want to SSH user at, and in this case my IP for that is 54.175.214.244. This IP will have changed by the time, of course, that you are looking at this video. We're going to set the user account password for root. So let's make sure we do a login, and then we're going to be prompted for a new password, which we're going to do now. And now we're logged in as root. So if we look at the man page for dpkg, which is dpackage, it just means Debian package. It's the package manager for installing, building, and removing Debian packages. The primary and user-friendly front end for dpackage is one of the others that we'll talk about, which is called Aptitude. Dpackage itself is controlled entirely via command prompt parameters, and the one that you're going to be using the most often is going to be -i. And -i will actually install a package, which we'll do here in a moment. Of course, all of us should be familiar with Apt Get. Apt Get is the most common interface for installing Debian and Ubuntu packages on a Debian or Ubuntu system. And Apt Get, what it does and how it differs from dpackage is dpackage will simply install the individual package for a single Debian piece of software. Whereas Apt Get will not only do that, it will read all of the dependencies that specific package needs and will give you the option to install them all so that your installation can be successful. And then Aptitude itself is a front end for dpkg and gives you a little more flexibility in terms of being able to look at what we have on our system. So one of the things that we'll need to do is let's make sure that Aptitude is installed. We are logged in as the root user. However, as long as you are logged in as a user with sudo privileges, these commands will work, although you will have to preface them with the sudo command. So let's do an apt get update, and this is the first thing that you're going to want to do the first time that you run anything on your system. What this does is it reads all the repository that are configured for this particular system and updates the cache so that when we search our system repositories for information about packages, it has the latest versions that are available from within those repositories. Let's go ahead and clear that. And then we'll do an apt get, and install is the most common parameter for apt get application usage. We're going to apt get install, and we'll install Aptitude. Aptitude is already installed and the newest version, so we don't have to worry about that. If we look at the man page for Aptitude, we'll see that it's a high-level interface to the package manager. And what does it look like? Well, let's look at what Aptitude looks like. We're running it in a command terminal, and there are GUI front ends for it, but we're going to concentrate on the command terminal. we simply have Aptitude telling us that we have 4 security updates and installed packages. We have 1,290, 43,000 of which are not installed, virtual packages and tasks, etc. So if we pick any one of these and we simply press the Enter key, it will tell us information about all of those packages that we have on our system. If we press Enter again, it will uncompress the installed packages. And if we go to the not installed packages, we can choose to install anything that we might want to do here. So if we wanted to install text editors and word processors, for example, we could press Enter here and look at what we might want to install. So we're going through the main process, and say we wanted to installLedit. TheLedit package for installation has a particular home page. Whether the priority is optional, it's an Ubuntu editors. It says it's available for all architectures, and the source package is calledLedit. So in order to download, install, or remove, all we're going to do at this point is we're going to hit either G or U, and we're going to install that particular package. Now, once we reread the cache that is available from our system, we'll go ahead and Q for quit, and we go to installed packages, and we should see in the editors area under main, we should now seeLedit. So let's go ahead and quit out of Aptitude. And so Aptitude's nice from a installation perspective to be able to work your way through a particular tree of package apps installations. However, you're almost always going to be using Apt Get and Apt Get at the command line. And again, there are front ends for Apt Get, but we'll look at Apt Get at the command line. So one of the things that we want to look at is another way of determining what is installed on our system if we're logged in as root or running as sudo. We can do a dpackage -L. And that will tell us all of the packages that are installed on our system. So for example, if we wanted to know whether the XAuth application is installed on our system, we could do a dpackage-L, and we could grep for XAuth. And it should tell us in this case that XAuth is indeed installed on our system, and it's version 107. So that's good information. Now, what if I wanted to know what was in the dpackage-L system? Or the dpackage, if I wanted dpackage to tell me what was in the XAuth system. Well, since I know the name of the package is XAuth, then all I have to do is a dpackage-L and XAuth, and it tells me all of the files that were created for the XAuth package as a result of its installation. So now dpackage is something I can use to install the package if I have the .deb. I can list all the packages that are installed on my system, as well as all of the files and directories that are created as part of the dpackage installation. So from an Apt Get perspective, then let's look at some of the things we can use from an Apt Get perspective. So for example, I can do the same thing from Apt Get using an extension of apt called Apt Cache. So if I want to know what package names are installed on my system, let's go ahead and clear this. I can do an Apt Cache and then pkg names, so package names. And it'll tell me just the names of the packages that are installed on my system. Now that tells me what's installed. What if I want to find a particular package and see if it's available for me to download? So I can do, for example, an Apt Cache Search, and then I can search for all or part of a particular word. So if I wanted to search for the word xterm, it'll tell me everything that has either in its description or in its package name the xterm text. So now what if I want to see using Apt Cache the package information itself similar to the dpackage-L? Well, in that case, I can do an apt cache, and since we used xoff before, we'll do show xoff. And that tells me a whole bunch of information about the package, and this is the same information that we could get from xoff if we were in Aptitude and we went through the tree and found xoff within Aptitude. All of this information, the package, the priority, the section, the installation side, homepage, all of this stuff is located and is read from the same place that Aptitude will use for installing packages or showing information about packages. Now, one of the things that you'll notice is that we're using this command called apt cache. Well, what is apt cache? So let's look at some of the statistics for apt cache. So we'll do an apt cache and we'll do stats. And this tells us that we have a total in our cache locally of 56,979 package names along with the structures. And then we have information about distinct versions and descriptions, dependencies, file version relationships and descriptions, mappings, blob strings, dependency version space, slap space, and space accounted for. Now, some of that information can be affected if we do a clean of the cache. So if we were to do an apt get auto clean, then what we will do is let's rerun our command for apt cache stats, and some of those numbers will have changed because we've cleared our cache. So one of the things that you'll want to do periodically, especially when you run lots of updates, is you'll want to run the apt get auto clean. It'll free up disk space and it keeps your internal cache database most up to date. Again, for updating the files in our repo, so if we're talking about files in a repo, if we go to etc apt, we'll see that within here is a file called sources.list. And if we cat out sources.list, we'll see that there are various repositories that are configured from within this sources.list. And when I do a apt get update, those configured repositories are being queried and synchronized so that my software package caches know how to install packages that we're getting. Now, if I want to upgrade my entire system, all of the packages that are on this system for the version of Ubuntu or Debian that I have, then I simply do an apt get upgrade. After you've done an update, that's important, is that you don't do the upgrade until you've done the update. The update will pull a cache or synchronize those caches so that the latest versions available for your repositories are updated as part of the update process. In this case, all that's available for us is some of the Linux headers, which is our kernel. We're not going to install that on this particular system. We're using a Linux Academy lab server. We'd have to install and reboot the kernel, so we're not going to do that. One of the other things that we can do is we can do a full distribution upgrade. So if we do a sudo apt get dist upgrade, this will upgrade my current distribution to another distribution that is up the chain. So in other words, if I'm running 1404, it'll upgrade to 1410 if that particular version is still under support. If not, it'll go to the next one, 1504, then 1510, etc. We're not going to upgrade the distribution, but what it will also do is that distribution upgrade will determine what packages are compatible with your upgrade and which are not. So now, how do I install specific packages or perhaps upgrade them? Well, there's a couple of things that we can do. We can do the sudo apt get upgrade, which will upgrade anything that has new versions on our system, or we can install anything that we want that's available in our repositories. So if we did that apt cache search and we said, is nmap available for our system? There it is at the top, and it's actually called nmap. So we'll go ahead and clear that, and we'll do an apt get install on nmap. And nmap, you'll see, has suggested packages and new packages that are required in order for nmap to work correctly. So we're going to go ahead and let the system download and automatically install and configure all of the packages that nmap will depend upon. Now I can install multiple packages while Nmap is doing this. I could have installed Nmap and Apache, for example, simply by listing all of the applications that I wanted to install, one right after the other on the command line. So I could have done, for example, an Apt Get install Nmap, Ncurses, Apache, Postgres, etc. And if those packages were available, it would install them along with their dependencies, one right after the other. I can also install several packages using a wildcard, but I caution you to use wildcard installations because you almost always will end up with a ton more stuff than you intended. So for example, if I do an apt get install on xtur, you'll see that there is a ton of things, including things that are incompatible, that I would have installed just by intending to install probably xterm. And in this case, if it had installed everything, I would have ended up with broken packages because certain packages are incompatible with others. So be careful when you're using wildcard installations. I can also use this to install a specific version that's available in my repositories. So let's look at something. Let's do a Apt Cache Search on xterm. Or let's say VSFTPD. So VSFTP is a package that's available, but what I want to do is I want to install a very specific version. So what I would do is I do an apt get install and VSFTPD, and let's say that the version 2.3.5-3 Ubuntu 1 is available for our system. Okay, in this case, it can't find that particular version. But if that particular version was available to me and was compatible with my system, as long as it could install the appropriate dependencies, then I would be able to just do an install by passing the version of the particular file. Now that I have Nmap installed, however, I want to remove it. So to uninstall software packages without removing their configuration files, in case we want to later reuse the same configuration, we would use the remove command. So we would just do, for example, an apt get remove and Nmap. However, if I want to completely remove everything in the system so that anything associated with the particular package that I want to remove is removed, including configuration files, I can do either apt get remove -- purge, which is the most compatible version, or I can do an apt get purge and then the package name. In my case, for consistency across versions of distributions and distribution types, I will use the remove -- purge, which will again remove every trace of the Nmap package once we apply it here. And you'll get the same kind of information that you got during install, because it will look and see what dependencies were installed and that they're no longer required. Meaning that if they're required for some package that you've installed subsequently, then you'll end up with those files will hang around and Nmap will say. Finally, if I just want to download a package and I don't want to install it, I can use an apt get command just to download it. So if I do apt get download Nmap, then we'll see that if we do an lsal star.deb, that my Nmap file is here. And then what I can do is I can do a dpackage-i on Nmap, but I bet what's going to happen is it's going to tell me I'm missing dependencies. Because remember, all dpackage is going to do is read that Debian package file and attempt to install it, and the installation will fail unless its dependency map has been met. In this case, Nmap doesn't need anything that I don't already have, and if I do Nmap, then I get the Nmap command. But be aware that if you do a dpackage-i and you don't have the dependencies that are necessary for that application to run, it will tell you what is missing, and you'll either have the option to go download those packages or use something like Apt Get that will allow you to install that. Finally, if I want to take a look at the change log for a particular package so I can see how it's evolved over time, I can do an apt-get change log and then the package that I want to do the change log on. So that particular package will tell me throughout its life cycle for various versions what the bug reports are, what date it came out, and who either assigned, built the package, or created the bug reports. So that's good information from an administration standpoint, just to see what we may have available. Finally, you'll occasionally install packages on your system, and you'll inevitably end up with what are called broken dependencies. And broken dependencies mean you've removed part of an application that had a dependency on another application, and you may want to understand what those dependency breaks are. So if we just do apt get and check, apt get check will tell us in our dependency tree, in our static information, what dependencies may be broken. Now, can I build and search dependencies depending on a package? Well, there is a command that will search the local repository and install build dependencies for a package. If the package doesn't exist in the local repository, however, it'll return an error code. So for example, I can do an apt get and I can do a build-dep and then the nmap command. So for nmap, the following new packages will be installed. And after this operation, we're going to use about 200 megabytes worth of additional space. So I've built a package dependency tree that tells me, without installing it necessarily, that what are the exact build dependencies for a particular application. And then finally, when we're done with our system and we're done with our package installations, then what I recommend is that we clear the cache, which is in var cache apt archives. So if we take a look at var cache apt and we look at archives, we'll see that we've got a whole bunch of stuff in there. So all we're going to do is, as we talked about earlier, we're going to do an apt get auto clean. And this will remove any of the .deb files from our var cache apt archive, so we've freed up the space that we took up for those particular archives. So package management within Debian and Ubuntu systems, again, to summarize, we've used dpackage to install individual packages. However, if those dependencies for that package installation do not exist, it will give you a list of them, but you'll have to install them manually. We've used Aptitude, which is a more comprehensive package management system that gives you kind of an ncurses GUI in your console for installing packages and their dependencies. And then the more commonly used Apt Get, which is a front end which will read the dependencies for a particular package and download and install all of them, as well as being able to remove the package and or all of the package contents and configuration files. So for software and package management on Debian and Ubuntu based systems, that's all there is to it. My name is Terry for Linux Academy.